Hey everyone. So this is going to be the second part of our video, and this is going to walk you through the lab activity that you guys are going to be doing around herd immunity. This video is meant to show you the data collection portion, how to collect your data, how to use the simulation. It also is going to explain what the simulation actually represents and how to enter that data into a class data set that we will then be talking about in class tomorrow. If you haven't had an opportunity to take a look at the video previously where I discuss the adaptive immune response, vaccines, and herd immunity, take a moment to do that now before you start to get into the actual lab activity so that you understand why we're doing this activity and what it's all about. Okay, so now that we've reviewed that, we're going to go into the assignment on Google Classroom. And you'll notice that there are 3 documents. We'll talk about these documents in a moment, but I want to start with this link right here because this is going to be our simulation. And this simulation that we're using is essentially demonstrating how measles spreads in 10 populations with different vaccination rates. These populations include 3 hypothetical populations, so you can see those right here, and 7 actual populations in Washington, California, and Florida. As you can see, the simulation runs immediately upon opening the link found in Google Classroom. So you'll notice these little red dots flying in. This is the simulation actually running. You should note the key at the top of the simulation, which is found here. Each dot in a population represents 1 individual out of 100 people total. Blue dots, okay, those are vaccinated individuals. Yellow dots are susceptible individuals who have not been vaccinated, and red dots are infected individuals. The yellow dot with a blue border, which you can see right here, is only found in 1 population. It's found in, 2 populations. It's found in these 2. And that represents a person who is vaccinated but is still susceptible to disease. This represents the fact that vaccines are not 100% effective at protecting all individuals from infection. These populations consist of individuals who are about the same age, are in close contact, and mix randomly. So take a moment to think about what kinds of locations would satisfy those requirements. So you notice that a red dot was kind of flying into each population when we loaded the simulation up. That represents an infected individual who is trying to come in contact with 1 random person in the population. So this event is going to happen 5 times. So an infected individual is going to come into the population and it's going to interact with 5 different people. And those 5 people will be selected at random. If the person selected is vaccinated, meaning they're blue, then the disease does not spread. If the person selected is not vaccinated, meaning they were yellow, then the disease will spread to that person. So now once the disease has spread to that person, it's considered to be a not protected community. Now, what can happen from there? Well, once 1 person is infected, each individual who is not vaccinated, so all of the yellow dots, have a 90% chance of also being infected. So if 1 yellow person out of those 5 interactions is chosen and they become infected, they have a 90% chance to spread it to this yellow person, and a 90% chance to this one, and a 90% to this one. In addition, every vaccinated person has a 1% chance of being infected due to vaccine failure. Note that the chance of a vaccinated person becoming infected is substantially lower than a non-vaccinated individual. You will notice that it only takes 1 member of a population to become infected to cause an outbreak. If any number of individuals in the population become infected, then we would refer to that population as not protected. The purpose of this activity today is to collect an individual data set that you will then contribute to class data set. You should record all of your data in the table on the lab sheet. A digital copy of this lab sheet has been attached to the assignment in Google Classroom. So let's take a look at that digital copy right now. So this lab sheet's going to have some background information on vaccines, some of the stuff we talked about at the top of the video. It's also going to have your data table. So this data table right here is the data table where you are going to be recording your data. Ignore this for right now. This is the class averages part of the data table. We're going to fill this out in class tomorrow once we have all the class data uploaded to Google Classroom. So now that we've reviewed the lab sheet, let's take a look at the class data sheet that can be found here. You all have access to this through the assignment. You all will have the ability to edit this and enter your data. So tomorrow we're going to be using most of our time in class to analyze the data that you guys load into the sheet. So right now this sheet is empty because you haven't put any data in. But after all the data is put in, after you guys have done this assignment at home tonight, we are going to use the class time to then look at the data set, look at our percent chance that each population is protected, and we're going to get a sense of where the threshold is for measles based on this simulation. You're also going to be asked to take this data and produce a digital graph of that data and print that out and submit that with your final lab sheet. So in addition to class data analysis, we're also going to be discussing the importance of herd immunity, and we'll be looking at the vaccination rates of different schools within our Ithaca community to determine which local populations are most or least protected in the event of a potential outbreak. We will be evaluating how protected our most vulnerable individuals are in each of our school buildings across the Ithaca community and discussing the ethics around vaccination exemption for personal or religious beliefs. This is an important discussion considering that upstate New York was on alert for a measles outbreak as recently as May of this year. Let's go through the data collection process. So the first step is going to be to run the simulation again. We're going to do that by clicking this red button at the bottom of our simulation. So click that, and you'll notice that it resets itself, and those red dots are flying in, and so that's showing us that the simulation is running. Notice that these populations are now not protected because at least one of those yellow individuals was infected by that red dot that's flying in. So we allow the simulation to run to completion, and then we're going to write our data in the data table on our lab sheet. So I'm going to pull up a digital copy of this lab sheet. You're going to be writing this in as you go. And what we're going to do is we are going to follow the instructions right at the top here. We're going to write NP if the population is not protected, or P if the population is protected. And this data table goes in order of increasing percentage of people vaccinated, and that is very convenient because our data simulation shows or has these populations in order from left to right. So you can see the first 5 here, these are our lower vaccination rates, and these are the ones that are our higher vaccination rates. And so you can go right in order and say, all right, the first 5 and then 3 are not protected. That's NP. So we're going to write NP. And notice that I'm entering my data into the trial 1 column because this is my first run of the simulation. If I go back to my simulation data, I notice that the last 2 populations are protected, so I'm going to put a P in both of those. Okay, so once you've done it once, you're going to run the simulation 9 more times to get a total of 10 trials. Once you have that 10 trials, let's just actually fill one out really quickly. So we'll just pick one, right? And we'll say that here's our data for this one. Okay, you're going to write a ratio in this last column. And so the ratio is going to be the number of times that population was protected compared to the total number of times you ran the simulation. So in this case, we have 3 Ps, so it was protected 3 times out of 10 total runs. So I'm going to rate 3 out of 10 here. Now, why does that matter? Well, you're going to be writing these numbers in on your data sheet or on the class data sheet on Google Classroom. So we're going to go back to that spreadsheet. And let's just say that I have a sample set of data to go ahead and enter. So I'm going to write my name in there. And then I'm going to write my data in. So let's say that the first one, the population 0 times was protected, I'm going to write a 0. Okay. Let's say it was 0 again and 0 again, and oh, now I have 1. You'll notice that as soon as I start entering numbers in, data changes down at the bottom. So this is set up so that once all of our data is entered, once all of our numbers are in, we will have a percent chance that that population is protected. So you're going to enter in the rest of your data. Once you finish doing that, I want you to go back to the article and read it. So there's an article down here. And you want to do this because we're going to have a quiz tomorrow. It's a pre-assessment quiz based on the reading of the article as well as the content of this video. As always, please reach out to me with any issues that you may have. Good luck with your data collection,